All right, so this one says a marble is launched from the floor at a speed of 6 meters per second at an angle of 29 degrees from the horizontal. How far away from the starting point will the marble land? So this is a classic projectile motion question. First thing we do is draw a picture. Here is our floor. Here's our marble. That marble is going to be launched at yeah, we'll do a velocity. Well, there's two things. The angle from here to here is 29 degrees. And the velocity, and we'll just call this V initial, is 6 meters per second. And so that thing's going to go like this and land right here, right? So this is just the range equation. So these are, I like these. These are pretty easy. So the range equation basically helps us calculate delta x. So the distance from here all the way to here, delta x. So delta x then is equal to 2 times the velocity squared times sine of theta times cosine of theta all over g. Remember that g is going to be a positive 9.8 because it's in the formulas as negative. Whoops. So I get a little frustrated. Some textbooks use the letter G. Whenever they use the letter G, they put in a negative sign or take out a negative sign based on the application. But this answer should be positive, if you're wondering. So then how do I do that? Well, I say that delta x is equal to 2. This is what you're going to need to write on your formula sheet, this thing right here. 2 times 6 squared times sine of 29 degrees times cosine of 29 degrees divided by 9.8. All right, so let me show you how to do that in Desmos real quick. The beauty of Desmos is that you can actually do it in one swoop. So I'm going to make a fraction. But remember, I got to tell the calculator to do the stuff in the top separate from the stuff on the bottom. So if I just say 2 times 6 squared times, and now look up here at the screen so you know where to find sine and cosine on this thing. If I hit function, there they are right there at the top. Sine of, and then I gotta go back, 29 degrees. See how this says degrees? This is radians. This is degrees. So make sure you have it in degrees. You gotta put it in parentheses too. The count, yes. Oh yeah, they're right here on the bottom. I show you this though because at some point we'll have to do arctan right here. But yeah, you're right. They're right down here too. So let's do it this way. All right. So we'll say 29 degrees. All right. And then we got to close the parentheses because I started parentheses. Okay. Let me double check. Do we have everything right? Yep. And then on the bottom, we just say 9.8. And if I round that, isn't that like 3.12? Yeah. So then over here, we would just say that delta x is about 3.12. meters. Yeah. I can.